we've now talked about 5 triangle congruence theorems. And now what we're going to do is we're going to use those theorems to now talk about the other parts of the triangle. And you may remember that when we talked about side, side, side theorem at the very beginning, and I'm just going to mark these for a minute to give you a reminder. And I said that this was the oh duh theorem because it seems obvious. Well, I have 3 pairs of congruent sides. Of course the triangles are congruent. Why do we need to use this one? And I told you guys that once we know the 2 triangles are congruent, by side, 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 that means we can also say that the angles are congruent as well. These corresponding angles would be congruent, and we can make that determination because we know the sides are congruent. So that's what we're going to be doing today, is that once we're proving that these triangles are congruent, we're going to prove that one set of corresponding parts is congruent as well. A pair of sides or a pair of angles are going to be congruent even though those aren't the ones we use to prove that the triangles are congruent. So we're first going to prove the triangles are congruent and then use that information to show that either 2 sides or 2 angles are congruent, that were not originally used to prove that the triangles are congruent. So let's look at this example here. We'll start with the basic one here. So we have AB is congruent to DE, and angle ABC is congruent to angle DEC, and that is given. So let's go and mark that up. We have AB is congruent to DE, and we have angle ABC is congruent to angle DEC. Now, if we look at the proof, the next part says that angle ACB is congruent to angle ECD. That's these 2 vertical angles here. So now what we can do is we can look at the top triangle and the bottom triangle and say that those 2 triangles are congruent by angle, angle, side, because we have 2 pairs of congruent angles and a non-included side. That lets us determine that these angles or these triangles are congruent by angle, angle, side. So let's fill these things in. Why were we able to say that angle ACB is congruent to angle ECD? Well, those are vertical angles. Vertical angles are congruent. And then doing that allowed us to say that the 2 triangles are congruent by angle, angle, side. Now, the proof wants us to prove that segment or side DC is congruent to side AC. Well, here's DC. DC. And here's segment AC. Those 2 sides were not part of any of the thought process or the proof to prove that these 2 triangles are congruent. But if these 2 triangles are congruent, that means their corresponding sides and angles are congruent. Remember back to the beginning of the unit when we were writing out congruent statements and we were able to match up the congruent parts of the congruent triangles. So if you look at the congruent statement too, you can see, DC, that's the first and last letter in the right triangle, and AC is the first and last letter in the left triangle. So you can see that those are corresponding parts. So the reason that we can say that those 2 segments are congruent is because the corresponding parts of congruent triangles are congruent. So that's a lot to write down every single time. So we can abbreviate that as CPCTC. Corresponding parts of congruent triangles are congruent. So we can use that to abbreviate that big long phrase there for reason number 4. All right, so first, again, we prove that the two triangles up here were congruent by angle, angle, side. And then we said, well, if the two triangles are congruent, that means their corresponding parts must be congruent as well. And AC and DC are corresponding parts, so they must be congruent. All right, let's look at another example. Example number 2 down here. We have BD is congruent to CD, and angle BDA is congruent to angle CDA. So let's write that given information down. And we also want to mark up our picture as well. Okay, so BD is congruent to CD, and angle BDA is this angle, and angle CDA are congruent. And what are we trying to prove? We're trying to prove that angle BAD is congruent to angle CAD. We're trying to prove that this angle up here, and maybe I should zoom in to help a little bit, and this angle, so these two angles in red, we're trying to prove that those are congruent. But let's not mark that down because it might confuse us. So as we're going through this proof, we kind of want to strategize what we're trying to do. We can see that at statement number 3 that triangle BAD is congruent to the triangle CAD. So that means that we want to try to prove that this triangle is congruent to this triangle. And now if we look at statement number 2, we have a blank there, but the reasoning is the reflexive POC. Reflexive POC, or reflexive property of congruence, happens when we have a shared side, which is side AD. So AD is congruent to side AD. Now, why can we say that those two triangles are congruent? We have two pairs of congruent sides, and angle D in the left and right triangle is the included angle. So we have side, angle, side. Side, angle, side. Okay. So since those two triangles, the pink one and the yellow one, are congruent, that proves that angle BAD is congruent to angle CAD. And the reason for that is your CPCTC. The corresponding parts of congruent triangles are congruent. If you look at our congruent statement, you see A and A are both in the middle. So we're talking about angle A in both triangles. Now let's look at the next page. We're proving that the diagonals of the rectangles are congruent. So what we're trying to prove is that segment AC and BD are congruent. Then those are the diagonals of this whole big rectangle. Okay, so let's write down our given information. And we have AD is congruent to BC. We have AD is perpendicular to DC. And we have BC is perpendicular to DC. So let's mark all of this up. AD is congruent to BC. And we have AD is perpendicular to DC. So that means there's a right angle here because here's AD and here's DC. So we have a right angle there. And we also have BC is perpendicular to DC, so we have a right angle there as well. So now, let's write down given. Now what we're going to do is we're going to look at side DC. If we look at this triangle here in purple, and this triangle here in, I don't want to use blue, let's use green, they both share side DC. So DC is congruent to CD because of the reflexive POC. And again, the reason why I changed DC to CD in the second part is because if you look at the purple triangle on the left, angle D is your right angle. If you look at the green triangle on the right, angle C is your right angle. So they are flipped. Now statement 3 is blank, but the reasoning for statement 3 is perpendicular lines form right angles. Oh, so that means that angles ADC and angle BCD are right angles. And we know that because we had those perpendicular lines that form those right angles. So we kind of did statement number 3 when we marked up our picture. And the reason why we were able to mark those angles as 90-degree angles is because we were told that we had some perpendicular lines up here. So then if those two angles are right angles, that means they're also congruent because right angles are congruent. So angle ADC is congruent to angle BCD. So statement 5 now goes to triangles. ADC is congruent to triangle BCD. And the reason for that is side angle side, because DC is congruent to itself. It is a shared side. So we have this triangle and this triangle are congruent by side angle side because we have two pairs of congruent sides and one congruent angle. That is side angle side. So now that we know those two triangles are congruent, that allows us to say side AC is congruent to side BD. If you look at our triangle congruent statement, AC are the first and third letters on the left side, and BD are the first and third letters on the right side. So those are corresponding parts, AC and BD. So we can say corresponding parts of congruent triangles are congruent. All right, now this last example, we're going to prove that the opposite sides of this parallelogram are congruent. So when I see these parallel lines, these arrows here, I know I need to think back to all of that alternate interior angle stuff and corresponding angle stuff and alternate exterior stuff that will help us prove that these two triangles are congruent. So let's get our given stuff. AB is parallel to CD and AD is parallel to CB. Remember, the two lines here means parallel. Instead of writing the word parallel every single time, we can just use that symbol. And that's given. So statement 2 and 3 are talking about angles. So what I'm going to do is I'm going to extend some parallel lines and see what angles are congruent to each other when I do that. So first statement says ADB and angle CBD. So angle ADB is right here and angle CBD is right here. So I'm going to extend these parallel lines because those two angles touch those two lines, and here is my transversal. And those two angles that I have in green are alternate interior angles. The angle ADB, the one on the left, is above the transversal, above the purple line, and over on the right side, angle CBD is below it. So those are alternate interior angles, and they are congruent. So the reason why those angles are congruent is alternate interior angles are congruent. Now I'm going to erase this, except the angles that were marked congruent, because now our statement is CDB, this angle here is congruent to angle ABD, this angle up here. So now I'm going to extend these parallel lines, and this is my transversal. And the reason why I switched parallel lines is because now my blue angles are formed by my pink lines, my horizontal pink lines, and the transversal yellow line going through. And again, those are also alternate interior angles because one angle is below the transversal and one angle is above my yellow transversal. So alternate interior angles are congruent. Then we have statement number 4. Well, statement number 4 is blank, but the reason is reflexive. Well, side BD is shared in both triangles, so that is congruent to itself. So we have DB is congruent to BD. So then that allows us to say that the top triangle here is congruent to the bottom triangle here because we have angle side angle. We have two pairs of congruent angles in the included side. So that makes these two triangles congruent by angle side angle. Now, if these two triangles are congruent, that means their corresponding parts are congruent as well. So AB is congruent to CD. Look at AB, the first two letters, and CD, the first two letters. Those are congruent. And the other thing we're trying to prove is that AD is congruent to CB. So now AD, the first and third letter, is congruent to CB, the first and third letter. So those are corresponding parts of congruent triangles, so they are congruent. So the reasoning is CPCTC. So I hope going through this has given you the reason of why did we spend so much time proving two triangles to be congruent using all 5 of those theorems. It's because now we're taking it to the next level and saying, okay, now that we know these two triangles are congruent, we can prove that their corresponding parts are congruent as well. So we can say that side AB is congruent to side CD because those are corresponding parts. And once we prove those triangles were congruent, we could then go further and say that those two sides are congruent as well. And then tomorrow we're going to take it a step further once we get all this stuff down. So thank you for watching. Make sure you hit that like button and subscribe.